Hello students, I hope that you are good, well and fine. Today, as we saw in the just previous session, we saw about the operations. Let me quickly recall you, okay, some of the operations we did. Okay, as we saw about the matrix addition, how we do the matrix addition by an example, let me show you. So we just add, first of all, the order of the two matrices must be the same, and then their corresponding entries must be added together like this. Okay, then you will have your addition. Okay, the same thing will happen for the difference also. Let me, for what? The difference, this a minus b difference, but this a minus b difference will be written as the combination of what? The sum and the this minus b thing. What is this minus b thing? This minus b thing is just nothing but the scalar multiple of b with -1. What is scalar multiple? As you can see from here, multiplication of a matrix by a scalar means what? Let me show you by an example, as we already covered this thing. That's why I'm going little bit fast here. So if a is given like this and you have to find 3a, then 3a means you multiply each entry of a with 3, like this you will get your answer of 3a. Okay, so this is what do we mean by what? The scalar multiple. And then we define our what? Difference of a matrix. So by an example, as we saw, if you have two matrices, you have to do what? The difference, or you have to find such thing. Then 2a means what? The scalar multiple, you multiply each entry with 2, and then what? Then this minus b can be rewritten as this. So now you have to find this, you will get the same answer as like this. Now this minus b can be obtained by just multiply minus b just multiply b with -1. Okay, this is what? Your scalar multiple. Now what you will do? You will do the multiplication with -1 to each entry of b. You will get your minus b and then add both of your outputs. Okay, simple. Now as we discuss the property of matrices in addition, you all know the commutative law holds. You add a to b or b to add, you will get the same answer. Okay, the associativity holds. You have three matrices, you add first two and then add the output to the third one, you will get the same answer. If you add the last two matrices and get this answer, that answer will be added to a, you will get the same answer. Now this property of additive identity existence, that you will have this O matrix, and this O matrix is just nothing but the ordered matrix. Okay, ordered matrix, and in this the entries of this O matrix will be all zeros. Zero matrix means, as the name suggests, zero matrix means. Okay, clear? Now when you add this matrix to a matrix, any given a matrix, you will have the output as a. Clear? And because of the commutativity, you will have a plus o or o plus a will give you the same output. Now the properties of matrices. In addition, the next property is additive inverse. The additive inverse, if you have a matrix A, then minus a will be its additive inverse. What do we mean by that? It's quite simple. If you add these two matrices, what you will have? The zero matrix. Okay, you will have the zero matrix. So that's why we call it as existence of additive inverse. Additive inverse means the such matrix which when added to a will give you 0. Okay, so now properties related to scalar multiplication. When you have k as your scalar and two matrices to be adding to itself, then this thing will be same as saying first this, if you find ka and then kb, then add, you will get the same answer if you add two matrices and then multiply with the scalar. Okay, the same thing happens here. If you have two scalar multiples and they are being added together and then multiply with a, the answer will be the same if you multiply your k scalar with a and l scalar with a and then you sum. Okay, I hope that you are memorizing or recalling these things. And we saw the answer for the just previous question. Now we were at this stage, the matrix multiplication. Okay, I'm not going to in this deep or whatever written in the language. I will be providing what do we mean by matrix multiplication by examples. Okay, as we saw one example, let me once again give you example. Okay, the same example. Okay, so let us see. So AB, this matrix multiplication is defined in what? So first of all, in order to define this matrix, the multiplication of matrix, you all know this is going to happen. Then you must have some order of A. This means, say suppose Mn. Then if you are going to write this B, then this B must have how many rows? This n much. So n times B. This means the number of rows in B must be same as number of columns in A. Then only you can define your product. Then only you can define your product. Simple. Now product will be like, how we define? Quite simple. Put a straight line or straight line segment like this, representing or like this. Okay, representing what? The first row of A. And now put the vertical lines, okay, vertical line in B at the first column. So now this thing will be multiplied this thing will be multiplied with this. So 6 times 2 will give you what? 12, plus you always add 9 times 7 will give you what? 9 times 7 will give you 63, and this will give you what? 75. So your first entry of AB will be 75. Now remove this. Now we vary this vertical line to this. Okay, this to this and this to this. This remains the same until we exhausted all the lines or line segments. Now we are at here. This means now I will be what? Or you can say like this. You can understood why like this also. So you have these. How many rows you will have? So 2 cross 2, 2 cross 3. So in total this will be cancelled because of the same. You will have 2 cross 3. So this means 2 rows and 3 columns. 2 rows. Okay, 2 rows and 3 columns. Now for this entry will be by this one like this and one vertical line, the first vertical line like this. So this means multiply this with this, this with this. You will, as you got this 75 here. Okay, now what about this entry? Quite simple. Now as you can see, this horizontal line is fixed. Yes, but this vertical line is now at the second column of B. Okay, so from this logic you can also understand the matrix multiplication, what is being done. Now 6 multiply 6, 6 multiply 6, 9 multiply 9. You will have 36 plus 81. Yes, this means 7. This means 117. Okay, if I am doing the calculation part wrong, please do the correct evaluation by your own. Okay, now for this you will have to jump to the third column like this. So 6 times 0 is 0. 9 times 8 will be 72. Yes. Now we are at here. So this means what? This means the second row. So second row, but the first column. So first column. Now 2 to 4. 2 to 4 plus 3 times 9 will be, sorry, 3 times 7 will be 21. 2 to 4, 21. This means 25. Now the row remains the same, or this horizontal line remains the same, but the vertical line changed to second column. 12. So 12 plus 27. 12 plus 27. You will have 12 plus 27 means 39. Yes, 39. Clear? Now the second or this horizontal line remains the same, but this changed to third. So now the final entry will be 2 times 0 means 0, 3 times 8 means 24. So your matrix multiplication for AB will be like this. and the entries will be like this. I hope that now you understood in different way that how you are going to supposed to do what your matrix multiplication. Okay, so I'll be giving you more matrix multiplication exam. First of all, let us see some of the properties or some of the things you must know about it. Okay, now you all know when you multiply two numbers, they follows the commutative law. Yes, they follows the commutative law, but in matrix it is not necessary. You won't always get AB equals to BA, not every time. Okay, not every time you will have this thing happening, or you can say in matrix multiplication it is not commutative. Not matrix multiplication is not commutative. Okay, matrix multiplication is not commutative. I hope it is clear to you. Let us see an example for that. So example is like this. As you see, first of all, let us satisfy all the criteria before multiplying. Can we do AB? If we can do AB, this means this is what 2 cross 3, this is what 3 cross 2, this is what 3 cross 2. Then you can easily see that yes, indeed we can do, and this AB matrix will be of 2 cross 2. Can we do B cross A? For B cross A, we first start with this B. B is what? 3 cross 2. B is 3 cross 2, and A is what? 2 cross 2. A is what? Sorry, A is what? 2 cross 3. 2 cross 3. Simple. Indeed we can do, and this BA matrix will give you 3 cross 3 output. 3 cross 3 matrix output. Okay, now this example also give you how we are going to multiply our matrix. Is quite simple. So like this, so 2 and this. So this means this for this and this entry you have to fix this line but vary these lines. Okay, clear? So that's why whenever you multiply your matrix, put this and this lines like, okay, then remove your first. Okay, for the respective entries put the respective lines so that you won't confuse. Okay, so this means 2 plus this will be multiplied with this means say 8 plus this will be multiplied with this means 6, so this means 16. Okay, so 16. Now what? Oh sorry, the minus is there. Okay, I somehow forgot this, so let me once again multiply. So 1 multiply with 2, now minus 2 multiply with 4 will give you minus 8. Now 3 multiply 2 will give you 6, so this means 0. Now for this entry you will have this multiply with this column. 1 multiply with 3 minus 10 plus 3, this means minus 4. Now for entries for this second row, how will you obtain? Quite simple, you will obtain like this. Minus 4 times 2 you will have minus 8 plus 2 times 4 you will have 8. Now 5 times 2 you will have 10. So this means this will be cancelled, you will have 10 plus 10. Now the last entry will be this multiply with the last column of B, which is minus 4 with 3 you will have minus 12 plus 2 with 5 you will have 10, 5 plus 1 you will have 5. So this means 15, and 15 minus 12 means 3. So the A cross B, sorry, A multiply with B will give you this matrix. And what about this? This matrix will be of 3 cross 3 like this. So 3 rows, 3 columns. And entries for this will be like this. Now we will, as B is given first, so this means we'll start like this. Okay, so this means this row will be fixed in what matrix? In B matrix. So this is now fixed. Now we will vary like this. Okay, simple. So these rows are fixed in which matrix? These matrices, and these columns will vary in what matrix? The second matrix we are given. As we saw in this, the rows were fixed like this in this manner because of this. Why? Because A is multiplied first to B. Clear? Okay. Now what? Now fix this. Now for this entry we have to multiply this and this. Okay, let us see. This means 2 multiply with 1 first, so 2, and 3 multiply with minus 4 means minus 12. Simple. So minus 10 you will have. Okay, clear? And one can directly also say that AB is not equals to BA. Why? Can you guess? Can you think? Why? Because if two matrices are equal, then they must have same order. First of all, they must have same order. As you can see, AB is of 2 cross 2 order, BA is of 3 cross 3 order. They cannot be equal to each other. In order to be equal, two matrices to be equal, they must have same order. So okay, but why I am doing multiplication? Because as much as you see how we are going to multiply two matrices, then up till that you won't feel uncomfortable with matrix multiplication. Okay, if you do not practice, then you will hesitate or you will do errors in matrix multiplication, because matrix multiplication is quite a difficult task for some students. Okay, so that's why I am doing matrix multiplication for you. So I will be mainly doing matrix multiplication as you verify by your own. I'm not giving you answers, but I'm just doing for you to verify things. If you do multiply your matrix by your own, and then just verify your answers to mine. Okay, then it will benefit you. Now for this means the second. So 2 minus 2 means minus 4. 3 minus 2 means 6. So this will be 2. Okay, now this. So 2 times 3 will be 6. Plus 3 times 5 will be 15. This means 21. Okay, simple. Matrix multiplication is not the difficult task, but you have to practice. Now the second will be fixed. Second column will be fixed. Now second row will be fixed, and first column, for this entry we have to multiply with the first column. So 4 multiply with 1, you will have 4. 5 multiply with minus 4, you will have minus 20. This means minus of 60. Now this 4 multiply with minus 2, you will have minus 8. 5 multiply 2, you will have plus 10. So this means 2. Now this 4 with 3, 12, plus 5 with 5, 25. You will have what? 37. Yes, 37. Now for this you have to multiply with the third row of B with the first column. So like this. So 2 multiply with 1 will be 2, and 1 multiply with 4, minus 4 will give you minus 4. So this means minus 2. Okay. For this entry, 2 multiply with minus 2 will give you minus 4. 1 multiply with 2 will give you 2. So this means minus 2. And the last entry for our matrix will be 2 multiply with 3 will give you 6. 1 multiply with 5 will give you 5. This will be 11. So as you can see, at the first stage we can also directly say that they are not equal because of the orders are different. Okay, and now also this is how we do our matrix multiplication. Okay, and this example shows that non-commutativity of matrix multiplication. Okay, non-commutativity. Okay, clear? Non-commutativity means in general AB won't be equal to BA. Okay, sometimes it may happen that they are equal, but not every time, as you can see here by this example. Okay, clear? Now another interesting property is that zero matrix as the product of two non-zero matrices. What it says, in real numbers, if you saw that you multiply two numbers AB, real numbers, and their product equals to 0, then what we say that we will have two choices. One, that either A is 0 or B is 0, or both of are 0. Clear? But in matrix multiplication, this can happen that multiplication of two matrices is 0, but neither A is 0 matrix. 0 means 0 matrix. Okay, 0 means 0 matrix. 0 matrix. But A cannot be 0 and B also cannot be 0. B also cannot be 0. But their product can be. How? Let us see. So A is given like this, B is given like this. So if you product AB, quite simple. How we are going to do the product? Quite simple. So first of all, verify this. So 2 cross 2, this will be cancelled. Your output matrix is of order 2 cross 2. Okay, yes, indeed we can do. Now what? Now for this, okay, for this entry, how will we take our thing? So this row will be fixed in A matrix and this columns will be changed in B matrix. So this, now 0 multiply with 3, what you will have? 0. So like this is what happening. So 0 multiply with 3 will give you 0. Now minus 1 multiply with 0 will give you 0. So 0 plus 0 will give you 0. Now for this 0 5 0 minus 1, so eventually you will get 0. Now for this 0 3 0, 2 multiply with 0 will give you 0. Now 0 with 5 0, so the final entry will also be 0. This means what? Now this is what your 0 matrix means, O matrix. So you saw that A is not 0, as you can see, B is non-zero, as you can see, but their product is 0. So in matrices, this can happen that the product of two non-zero matrices will be 0 matrix. Okay, please do memorize this point. It is very important. Okay, from the perspective of MCQ type of questions, this is sometimes asked to you. Let us move to next. Okay, now properties. Let us see some properties of matrix multiplication. So in matrix multiplication, we follow the associative law. This means if you have 3 matrices like this ABC, if you multiply first 2 matrices and then multiply the output of these 2 matrix multiplication with the third one, the C matrices, this will be same as if you multiply last 2 matrices with the output of the last 2 matrices with the A, like this. Okay, this will be what your equal. This will give you the equal output. Now distributive law, if you have 3 matrices A, then what you will have that this is if such sort of thing is happening, what do we mean by this? B is added to C, then that output, the sum, will be multiplying with what? A. A is now multiply with this sum. Okay, this will be same as saying if you find AB and AC and then add, then you will have what? AB plus AC. Then you will have AB plus AC. Clear? Okay. Now the second part, what it say? Quite simple. The second part is saying that if you in here you are adding to the left, this is my right, this is my left. Okay, but if the addition is done in this way, then can we do the distribution? Yes, we can indeed. So this means first of all this will be multiply this and this will be multiply with this, but to the left, sorry, to the right, as you can see, C is multiply with A to the right and with B also to the right. Okay, we are pleased to keep this point in mind that we are not writing CA and CB. Yes, we are writing AC because this C is multiplying with A but to here. Okay, AC and BC, this will be correct. This won't be correct answer. This won't be correct. If you interchange their position, this won't be correct. Why? As we saw that this is not equal to this. Sorry, this is not equal to this, not in general. Okay, that's why we cannot manipulate their order. So the point for the order will be same here also. So A is multiplied with B. As you can see, AB, this order must be in this particular way. Okay, A multiply with C, AC, we write AC, not BA, not CA, nothing else, just this. Okay, I hope that it is clear. Now, existence of multiplicative, existence of what? Multiplicative identity. Now, existence of multiplicative identity means that we must have some matrix I, what we are calling it as I, such that if you multiply your matrix A with I in this way or in this way, AI or IA, you will have the same output as A. You will have the same output as A. This is what we call multiplicative identity. Multiplicative identity. Okay, clear? And this identity must be of same order. Let me give you, if A is M cross N, this means I will be what order? As you must have N cross M. Not same order, but what can you say? What can you say? Like this. Yes, if you try to find this will be what? Say 1 cross 2, like this. 1 cross 2. Then if you multiply this will be like this. Output will be what? M cross M. Output will be what? M cross M or 2 cross 2. Then your identity will be, as you can see, in this way. But okay, what I'm trying to say is this: if you have a matrix of order M cross N and identity matrix of order N cross N, and then you multiply, suppose you multiply like this, then your output matrix will be what? M cross M. But this means this cannot be equal to A. But what we want, we want such matrix I such that the output must be A. The output must be A. So for example, that's why I took this example. This is what? 2 cross 1, and this is what? 1 cross 2. And the output will be, if you try to see, the output will be for this will be 2 cross 2. Something like that. 2 cross 2. But this, so you can directly say that this is not equal to this 2 cross 2 matrix. Okay, so please, in such condition you cannot find your I. In such condition you cannot find your I. I'm trying to say that you have to find this thing, then this thing is directly imposing one thing, what? That if in general you put your A as of this order, then you cannot find I in easy way. Or okay, so this means what? Your A must be of square matrix. So that's why this is written over here, that for every square matrix A there exists an identity matrix. Okay, we are not talking about in general M cross N. We are not talking about in general M cross N matrix. We are especially talking about when we have A as our what? Square matrix. This means row and the columns, the number of rows and the number of columns must be same. Okay, I hope that you got the main essence of this little words written over here. Okay, then only you can have an identity. Okay, in general you cannot have M cross N. So in that case, so this means M is of M cross N and I will be of what? This means, can you do what? Can you do such sort of thing? No. Why? Because the output matrix now will be of M cross N, but we want A here and A must be of M cross N. So this means this I also must be M, the square matrix. Okay, please, as it is already written here, there exists an identity matrix of same order. Now you have understood everything, every word in this third point, that why we needed A as a square matrix, why the existing identity matrix is of the same square matrix, as you can see. Okay, now let us take an example. Suppose you are having this a sort of A, then the identity matrix will be this. Okay, if you multiply, you will have what? 1, 0, this means 1. Now multiplying with this, 0 and then 1. Okay, now this will be 2 multiply with 1, 3 multiply with 0, 2 multiply with 0, 3 multiply with 1. So you saw that A. So in general, if you are having A is equals to of M cross M order matrix, anything, say A11 till AMM, okay, A1M, AM1, this M cross M square matrix, then your identity matrix of M cross M or IM, in short we write like this. Okay, this will be what? 1 0 till 0, 1 1 till 1. Okay, how many rows you are having? M rows. How many columns you are having? M columns. And the entries where we are having 1 are the diagonal entries, principal diagonal entries. Okay, as you saw. So matrix, identity matrix of order 3 will be what? 1 0 0 0 1 0 0 0 1. Okay, and I2 we already saw that. I4 will be like this: 1 0 0 0 0 1 0 0 0 0 1 0 0 0 0 1. Okay, I hope that it is clear to you. Let us move to the next slide. Now here what it is written, quite simple, that A is given like this, B is given like this, C is given like this. So you have to find your this A and then BC. You have to find the first AB here and then multiply with C, then find AB here, then multiply with C. Then what you have to do, verify or show that this is equivalent to each other. This is equivalent to each other. This is what your associativity thinks. Okay, so please do it by your own. Okay, so that's it for now. Thank you all having with us. Thank you for your attention.